Out we needed to restrict the domain in all when I'm taking the square root for the inverse function. That gives me a clue I need of positive numbers, that 0 or positive. So that's going to happen for all square roots, and that you're going to use in 10.2 as well. The domain needs to be restricted so the inverse stays a function. Then we found out the steps to find an inverse. We changed the f of x symbol to a y. We switch the variables. That's when inverse happens. And then we have to solve for y so we can use inverse notation. Then, since when I put the two functions together as a composition, either way, I can put the inverse inside the original or the original inside the inverse. I get x. So that's a story on, I think, one problem. You have to tell that story. Otherwise, it's just a statement in your story on your homework problems. So this proves that what we found up here was the inverse function. Now we get to see the graph. And the cool thing about the graph, it's symmetrical. So you'll be able to tell easily from your choices which one is the right graph, because they'll only offer you one symmetrical graph. And that symmetry goes across the diagonal line, y equals x, because in an original function and its inverse, you switch those two. So my original function had a vertical compression of 1/2, so it's just a little wider. It goes like that. And then my inverse function would be flipping. Whoa, I almost got it. It's supposed to be crisscrossing on that dotted line here. You make that a better curve this way, and then when I flip it, it crosses there. There you go. So I think the one in the homework, it's not such a big loop. Let me show you what it looks like. Yeah, they just have a little loop, but there's just a loop there. They count by 2s, that's why their loop got little. But you see the symmetry? Looks like a butterfly body. It's bugs, antennas. That's how I visualize what a function and its inverse look like on a graph together. So the original one was a parabola, like a bowl, but we restricted it because we need the x's to be 0 or positive. And then its inverse looks like a, it's like you're shooting a basket, but it doesn't come back down again. It just goes, maybe you're flying a paper airplane or something like that. The trajectory as it starts fast and then it slows down over time. Kind of like this. It starts fast and then it slows down over time. That's how they relate. So and when you go to find your graph on your homework, you are going to be looking for symmetrical. Mine happens to be letter D. Okay, so graph's not difficult. If you're on your homework, that's fine. If you're taking notes, that's good. Okay, but you got to do one or the other, right? Take notes or be on your homework. A little of both would be good. Time efficiency, right? Time management and understanding. Okay, so get engaged, whatever you do. Engagement now, you'll reap the benefits later. Okay? So here we go. What we did for number 1, we're going to do for 2, 3, 4, 5, 6, and 7 and 8. Some of them have graphs, some of them don't, but the graphs are just symmetrical. And again, use Desmos to solidify your thinking as well. You want to be a good math detective. Always searching for the truth. Always searching for the truth. So this is day 2, period 5. Lesson 10.1, And what are we doing? Finding inverses. That's when we switch the x and the y value of quadratic which are the x squared functions and all their transformations, and cubic. And they're simple. Don't want to get too complicated yet. We'll save that for grad school, right? Cubic functions. So you're working with simple. Maybe I'll write that up here to make sure you know there's more than what we're doing. We're in the kindergarten of inverses. But if you know how to do it, you can do it. Okay, so number 2 has your original function. With the multiplier of 9. So that's a vertical stretch of 9. Remember ABHK, you always want to be able to talk about that in your conversation about functions. We have to restrict the domain. That's the new idea. You've never done this before. So I want you to understand why we have to do that. So if I take the square root to undo this squared, then I can't take the square root of a negative number on a real number graph. Okay, the restriction is the set of all x has to be greater than or equal to 0. Now, since there's a multiplier, that's going to be all your story for all the restrictions. This function's inverse still needs x to be greater than or equal to 0. Okay, change your function notation to a y. These steps are not, if you're paying attention, these are very, very clear steps that you can apply every time when they ask you to find the inverse, like on a college career ready test. So change the function notation to a y so you can switch the variables. That's when the inverse happens. But in order to use the function inverse notation, we need to solve for y, undo a multiply by divide, and then take the square root of both sides. And I think on number 2, they even have the square root sign for you. All you have to put inside the square root is your fraction x over your multiplier. Notice, look at the original. It's being squared, it has the square root. It's being multiplied by 9, it's divided by 9. Very logical why this is the inverse. So this still needs to be bigger than or equal to 0. So the domain in all the story for number 2 is greater than or equal to 0, greater than or equal to 0. However many times you have to repeat it, it's greater than or equal to 0. We're going to write the graph. Okay, this is a really, this one really goes up fast because it has a vertical stretch of 9. So across this line, y equals x. So it goes up fast and it goes out fast. So it's got a symmetrical look. On the homework, you see mine was A. But you see how this one, if you fold it across the blue line, things don't match. That's how you know if it's symmetrical. Fold it across the blue line. These lines up here don't look like these lines down here. Fold it. Oh, the blue line isn't even in the right place for D. So they ran out of distractors there, huh? So that's what you're talking to me about. What good is this? Well, when you go to do 10.2, it's going to be handy. What a square root graph looks like. Remember, this one that flew up quickly is the original graph, and the one that flew right quickly is the inverse graph. Okay? Graphs, they're so abstract, but they're so practical. This is how decisions are made to solve problems. My son said it well last night when we were talking about things. He said if it was easy to solve, it's not a problem. So that's when you guys are working with these difficult ideas in Algebra 2 and beyond. It's so good for you. So good for your brain. Give your brain a chance. You can do it. Remember, if it's easy to solve, it's not a problem. And as we've said, easy is earned. Oops. Okay, this one's just a little different because when they ask us to find the inverse, we start with a restriction. There's an R here. Domain has to be positive numbers to start with, okay? And 0. Just can't be negative. But here's a little twist on number 3. When I find the inverse, change it to a y, switch variables, solve for y, I take away 9 from both sides first. Always take the root last, okay? Unless it's taking over the whole, like the whole expression's being squared, then you'd find the square root first. But when you have a choice between the inverse of add and the inverse of square, okay, right here, that's why we move the 9 first. So I have x minus 9, and we isolate the squared term, so then when I take the square root of both sides, I've got what I want. Sorry, that root isn't very good. So square root of the entire story, x minus 9, that's the inverse. So the game has changed. If x is 0, I've got myself a negative number underneath. So I have to start the domain in my inverse function so that x is greater than or equal to 9. Because 9 is what makes it 0, and any larger number then will keep it positive. But anything smaller than 9, 9.000000001, I have myself a negative under the radical. It's not graphable. This would not be a function because you'd have more than one x that belonged to a y. So here we go. In your homework, they're going to have you write the story about the original function where the domain is greater than or equal to 0. And then when they start talking about the inverse function, you're going to switch up the restriction. So they'll start you out with the original function. They'll have you talk twice about this one. So this will show up at the beginning. This guy is in the middle, 2 stories, and then you go back to the original function in the end. And I'll tell you what I'm talking about. Okay, ready? See up here? They give the story about the original function, and you're using, this is still original, in this first sentence. It says, since the inverse and composed with the original is x, for x is greater than or equal to 0. So 0 starts the party. Then in the middle, they talk about the 9 for the inverse, because they're putting the inverse in there. So the inverse you type in for x is greater than or equal to 9. That's already there. Then you end the story with the original function restricted at 0 and above. So that's what, when you're going to do number 3 and 4, and some of those that you have to talk about 2 different, I don't know, maybe 4 doesn't have it. Anytime when you're changing the inverse, when you have a different value that will make this 0, then you've got to change your story. If it doesn't need changed, it won't. Like number 2, we didn't need to change it. All was greater than or equal to 0. But number 3, because the inverse had to subtract 9 underneath of it, then the story had to change here. Okay. So just visualizing what you got to look at your homework. Okay. Now the graph. The original is up 9 units. So let's say that's 9. And then this is f of x, restricted for positive numbers. And then the new one would go, x has to be greater than or equal to 9. So you'd scooch over this 9, wherever, 2, 4, 6, 8, 9. I'm being chintzy, making my picture little. Okay, there's the reflection. This is the original. This is the inverse. And it's still symmetrical. That's a beautiful thing. All the ones they choose for you. You know, the choices they give you, there's only one that's truly symmetrical. So this is the new one, this inverse of the parabola that we have already known how to graph. This is what we'll see in 10.2. Is a square root function. It starts, it goes up, and then slows down, kind of like I don't know what object would have this, you know, this kind of arc. Whatever you have to take the square, whenever you have to take the square root, you notice where it's living. It's above the, you know, in this first quadrant because x has to be positive to go inside the radical. Okay, give your brain a chance to understand. This all makes sense. It's all one big story. A function and its inverse. 9 was being added up here, it's being subtracted down here. X was being squared up here, it's being square rooted down here. You know, when you're faced with find the inverse of this function, the pattern is the same. You do the inverse operations in the right order on your original function. Okay, number 4. We'll do some more square roots and then we'll get into the cube root story. They just make pretty graphs, and there's no restrictions because I can take the cube root of a negative number. Nobody gets hurt. If I take the square root of a negative number, there's a problem. This one's very similar to your last, your number 2, but no graph. Remember, there's a restriction on the domain. Oh, pickles. I wrote that the wrong direction. X cannot be less than 0. It can only be greater than or equal to 0. Because when I go to find its inverse, I have to take the square root of a number. Oh, pickles. Here we go. Switch now. Hopefully you're feeling it. You guys taking notes. Very smart. You feel it. It's like muscle motor memory. Why do I remember this stuff? Because I do it over and over and over again. It's amazing. Just like kindergarten. Okay, I switched them, solve for y. Got to divide first. And take the square root. And in your software, you get to put in x over 12 under a radical, everything. And you have your inverse. And that's it. Everything else is, the domain is restricted to greater than or equal to 0. I think you have to type this in twice in the story. This is what your story says. And it's very clear where you type it in because it uses this notation. Remember why things are the way they are. So I can't take the square root of a negative number, and I inverted all the operations from the original. That's the game we're playing. How about you? Now this function's got that x squared minus 1/5. So that means we're going to have to change up the restriction after we find the inverse because something's being added or subtracted there. It'll change the story. So at the beginning, we restrict it to positive. Oh, pickles, I'm making up my own problem here. There we go. Then I switch variables. I get in a hurry, yeah? You guys ever do that? Oh, never. Okay. Then solve for y by adding 1/5 first, please. The delight of Algebra 1. Take the square root of both sides, and you get to type in your software this little story, x plus a fraction. And this is your inverse. But we have to put restrictions on what x is now. Because if I put in, let's see, negative 1/10, it's still a positive number. So the new restriction has to be right up to the point of negative 1/5. What makes it 0? And above on the number line. So if I stayed at 0, there's all these infinite numbers here that will still make that positive. So I can't leave those out of the picture. Remember A, B, H, K, that's H. But we don't have to do the graph on this one. I'm just showing you. We don't want to leave out this infinite set of numbers, so that's why we had to change the restriction. And remember, you're talking about original function, this beginning of the story and end of the story. If you're talking about the inverse of the function, this guy goes in the middle. So you got to be ready for anything. Oh, and this number 5, they also have the little story. If I take the composition of its inverse and the original, remember that's x. So that's a part of your paragraph for number 5. So this guy goes at the beginning and the end. This guy goes in the middle. Beginning and end, middle. Beginning and end, middle, middle. There's 2 middles and 2 beginning and ends. Or beginning and an end. So 2 middles, beginning and an end. And you're like, this is like, you know how you have sentence starters in English? These are just sentence starters. They have sentence starters for you in math. And you're just filling in what you found to be true for this function. And its inverse. So remember what story you're trying to say. Am I on? I am. Same song, 6th verse, original function. Remember? Can't divide by a decimal and be done. You gotta simplify that. Okay, it says restricted domain is the set of all x such that x is greater than or equal to 0. And since that's a multiplier, I don't have to, there's no other restrictions, nothing will change. It stays this all the way through the story. switch variables. I think in the book they have you solve for x and then switch variables. I like to switch variables first because I forget. That's why I do that just a little differently than the book. And it's like potato, potato. No one way is right at this level of mathematics. Hopefully you're ready to fly out on your own. You can't, I'm sorry, you never really divide by a decimal. You have to multiply by its reciprocal. You know, to finish the story. So you can put this in your calculator and change it to a fraction. Remember how to do that. See if it's still on my calculator. Nope, it's not. Okay, so I'm going to put in a fraction, 1 over 0.3, and I get a decimal, and remember we have this toggle button down here. This guy right here will give me the fraction. That's what I'll need for my homework. And hopefully you saw the reciprocal of 3/10 is 10/3, right? They want the variable out to the side. So just to be safe, don't put it next to the 10. Scooch it out when you put it in the software. So in the software, you're going to have the square root. You're going to put the fraction 10/3, scooch it out to the side, and put an x. And you're done with number 6. Everything's greater than or equal to 0 for the restriction. Because nothing changed as far as what would make this 0. What would make this negative? Any negative number would make it negative. Any, 0 and above will make this square rootable. The restrictions are to make sure the inverse is square rootable. Number 7. Okay, back to a graph. Oh, yay! 7 is where we hit a function that's a cube root. And you'll like these because you don't have to restrict anything. Because if I take the cube root of a number, it's, even if it's negative, it's cube rootable. Now here's where I'm going to give you some safety tips. When you're using the cube root on your tool on your iPad and in the calculator, you have to make the 3, put a 3 in, second, hit the second function of the caret, so the 3 pops up in the, like a superscript. If it's not a superscript, you'd be wrong. And when you enter your answer into your homework, that it's got to be a superscript or you're wrong. So be careful when you're entering the cube root story. Okay, restrictions. There are none. So we go right to the y. And then we switch variables. Then we solve for y. Can't divide by a fraction and call it good. I've got to take 1 over 0.25 times x is y cubed. Flip it over, it's a 4. You check that in the calculator. Then you take the cube root, has to be a superscript up in the corner, inside your crevice of your radical sign. And this is your inverse function of your cubic function. So the graph is beautiful. An original cubic function goes like this. Makes that S road. That's pretty nasty. Then when I take and reflect it across the x-axis, its reflection, I'm going to do the curve first. And it goes like that. So it makes instead of going up the road, it's going side the road, right? And so you obviously see the symmetry. But the beautiful thing about a cube root is that it is all x's allowed. If you take the cube root of a negative number, let's do negative 27, I have a value. If I took the square root of a negative number, it'd say domain error. So you know you can, and obviously that's it's sketchy, right? Let me see, it's B for me, more or less, and we're over halfway. They have a couple of cube root graphs, and then they'll get you just back into the cube root story. So yay for cube roots. This will be 10-3. This is no restrictions. 10-3, we'll just look at, I'll mark this. This is F inverse of X, and this is F of X, okay? So the inverse is the one that's squirting out to the side. The original goes up to the sky. The inverse takes a lot longer to go up. We'll do one more quick. No restrictions. And sketch the graph. Then we'll be caught up. F of X, negative 18x cubed. You know what to do. No restrictions. Don't do that yet. Switch variables. Get all excited. I checked it in the software. I believe they want you to leave the negative down by the number. And cube root's song is sweeter. The only place you're going to be wrong is if you don't put that index correctly in your software. It's not next to it, it's inside of it. And this graph has a horizontal compression of 18 negative, and so that means it's going downhill very, very, very quickly. So this guy is the F of X, and then you see the symmetry here. This guy makes its little turn like that. That's the inverse. So symmetry, symmetry, symmetry. Pinwheels, remember, if you remember graphing cubic functions, the reason why it goes downhill is because this negative, and I'm done. I bet you are. Stick a fork in it, right? Done too. Let me see, it is B for me. You guys can get all but 10 through 12 or 9 through 12 done, and maybe you could even do that. If you get the pattern, you don't need them. But we will do them on Monday, and work day on Monday. Should have plenty of time for work, and lay a great foundation for this module. This is where it starts.